Hi, so today we're going to take a look at this rocket problem, which is problem 11 on the tutorial sheet. The question is asking us to model a rocket that's been projected vertically into the air. Now what that means is it's being projected with an initial speed, which was called u, but once it's in the air, there's no more forward force pushing it up. That's what projected means. It means it was given an initial push and then left. So when it's in the air, the only forces acting on it are, first of all, we have mg acting downwards, mg. The second force acting downwards is the drag resistance, which we're told in the question has a magnitude of 4.905 mv, where m is the mass and v is the velocity. So mass is in this equation as well. It doesn't matter, it's just a resistive force. We take the whole thing as a force. Now, the rocket is of course moving upwards. We need to remind ourselves that. So that's going to be our direction of motion. Now, let's use Newton's law to model the equation. So, the sum of forces in y direction, we're moving in y now, equals ma in the y direction, with up as positive. Now, both forces are going down, but of course we're moving up, so up is positive, down will be negative. So it's going to be minus mg minus 4.905 mv equals to ma. Now you can see immediately that every term has m, so we can cancel all the m's. You can only do this if every single term of your equation has m. So let's rewrite our equation again. So minus g minus 4.905 v equals a. Now in previous videos, I've said there's two ways to write a. A is either dv over dt, the change in velocity with respect to time, or it's v dv over dx. And if you want to see how we get the v dv over dx, visit one of my previous videos and you'll see how we get it. This question, you can see that it wants the final equation in the form v dv over dx. So what that means is we need to change a to v dv over dx. So minus g minus 4.905, this is the same thing as above, equals a, another way of writing a is v dv over dx. Now, let's write gravity minus 9.81, because we have to take common factor. 4.905 v equals v dv over dx. Now the common factor on this left side is basically 4.905. So let's take minus 4.905 out of the equation. Open bracket. 9.81 divided by 4.905 is 2. 4.905 divided by 4.905, of course with negatives both way, is going to be plus v, because we have a v there as well, equals v dv over dx. Now we can compare it to the equation that's given in the question. The question says minus d, open bracket, e plus v, close brackets, equals v dv over dx. So we can clearly see that d is equal to 4.905 and e is equal to 2. That is our two constants that we're asked to find. So part B basically says that we need to solve this differential equation that we derived in part A. Now, the first thing we have to do is separate the variables. So let's start by multiplying both sides by dx. So the equation becomes minus 4.905. 2 plus v of course stays there, multiplied by dx equals v dv. We've moved the dx to the other side. Now let's divide both sides by 2 plus v. Now, so it's going to become minus 4.905 dx equals v divided by 2 plus v, all multiplied by dv. Now we have v on one side. You can see here all the v's on one side, and we have x on the other side with a constant here. So next step is to integrate both sides with respect to their individual variables. Now we have a problem here. This kind of fraction is a special fraction in maths. It's called an improper fraction, and the reason is the top is the same power as the bottom. Or in the other case, if the top is the higher power than the bottom, it's also an improper fraction. Either way, it's an improper fraction. This one here, the power is the same. So we need to change it to a proper fraction. And the way to change an improper fraction to a proper fraction is to use long division. So we need to do long division. Now we divide the denominator here, which is 2 plus v, or v plus 2, it's the same thing. So we put this on the left side, v plus 2. And inside here we put the top of the fraction, v. So you put the numerator here of your fraction, and you put the denominator here of your fraction. Of course, I've put v plus 2. It's the same thing. 2 plus v is v plus 2. Now let's divide. First thing we do is we take this v here, and we divide this v by that v. V divided by v. V divided by v is equal to 1. We then multiply this one by this v and put it there. So 1 times v is v. We then multiply this one by this 2 and put it there. So it becomes plus 2. Now, since we don't have anything next to this v, we need to put plus 0 because we're going to subtract the 2. So you always put plus 0 and you subtract. So v minus v is 0. 0 minus 2 is minus 2. So what's that done is it's changed our fraction. V divided by v plus 2 is identical to 1 minus 2 over v plus 2. That's the whole point of this. You can see here we had an improper fraction. You can see there. Now we have a proper fraction. The top is not, it's not top heavy, or it's not the same as the bottom, the power of the variable. You can see there's no variable at all here now. Now we can put this, replace with this, and we can continue to integrate. So it's going to be integration of minus 4.905 dx is equal to the integration, let's put our new fraction, of 1 minus 2 over v plus 2 dv. So one more step I'm going to write before we integrate, and that is the integration of minus 4.905 dx is equal to the integration of 1 minus, let's take 2 outside, so it becomes 2 multiplied by 1 over v plus 2. It just makes it easier when you integrate, as we'll see in a minute. So it's going to be, the integration left is going to be minus 4.905 x equals, the integration of 1 is v minus 2. Now, the integration of 1 over v plus 2 is going to be ln v, because the differentiation of v plus 2 is 1, and that is 1, so we can use our rule that we've used in previous videos, f dash x over f of x. So it's going to be ln v plus 2 plus a. This is called the general solution, GS, the general solution, because we need to find a. So let's calculate the particular solution. Now we're told that when the rocket is projected, so when x is equal to 0, no distance has been covered yet, the velocity is equal to u. It's the initial speed. Substituting these values into our general solution above, we have 0 equals u minus 2 ln u plus 2 plus a. We can clearly see that a is equal to positive 2 ln u plus 2 minus u. That's the integration constant. Now substituting this integration constant back into the general solution will give us the particular solution. So we'll have minus 4.905x equals v minus 2 ln v plus 2 plus 2 ln u plus 2 minus u. That's our particular solution. Now, let's multiply everything by minus 1. At the same time, I'm going to take these numbers here to the power, using the power rule of logarithms. So we're going to have 4.905x, we've multiplied everything by minus 1, equals minus v plus, we've taken the 2 to the power, so it becomes ln v plus 2 all squared, minus, again, take the 2 to the power, u plus 2 all squared plus u. Now, let's use the laws of logarithms again to combine the two lns. We're going to have ln v plus 2 squared divided by u plus 2 squared plus u minus v. And this side will remain unchanged. Now, final thing, let's divide both sides by 4.905 to get x as the subject. X is a function of v. 1 over 4.905, open bracket, u minus v plus ln v plus 2 all divided by u plus 2, and we can make the whole thing squared. And that's our final solution. So, the final part of the question says, if u is equal to 10 meters per second, find the greatest height that the rocket reaches above ground. Now, the greatest height will be the maximum height the rocket reaches. When it reaches that height, it will stop, so its velocity will equal 0. So at max height, so greatest height, we know that v must equal 0. It stops instantaneously before falling back to the ground. So we have our two values here, v equals 10 and v equals 0. Let's substitute them above and find x. So x will equal 1 over 4.905, open bracket, 10 minus 0 plus ln. Now, 2 plus v. v is 0, so the top will be 2. Divided by 2 plus u. u is 10, so the bottom will be 12, all squared. Now, x is equal to, keep the 1 over 4.905 out here, multiplied by 10 plus, now 2 divided by 12 is equal to 0.16, or 1 over 6. Square that, you get 0.02. The ln of 0.02 is negative 3.58. So 10 minus 3.58 divided by 4.905 gives us x value of 10 minus 3.58 gives you 6.42, all divided by 4.905. It gives you an x value of 1.3 meters. So this rocket doesn't go very far. It reaches 1.3 meters